Lucy gets another shout out. Lucy, I can't find your comment, so I'm giving you a shout out. You explained to someone my thought process, how I do it organically like this, and I lead you people up to it. I don't just do a one off. There's ultimately a goal that I'm getting to, and I give you the background data first. So, first, you just get data, and it may mean nothing to you at this time. But once you get all that data, and then we come over to the next step, you'll say, oh, that other data matches, I get it now. And so that's the way I do it. I just don't cut to the chase sometimes. Or I might cut to the chase and then give you the background data, which we're at now. So this is punch shear protection. So these are mats. The reinforcement, you can see it's significant. It's going multiple directions. On our failure, we don't have multiple directions. On our failure, we have column. It's sheared from the decking, sheared from the columns even. There's not enough of it. And here's the pier head, the head of the piers from the parking garage. The deck was sitting on top of here, and we get this silly 4 pieces of rebar going each direction roughly. And to your left, oh, can I get to the left? And here we get, 2 this direction, 2 this direction. This is 1976 documents, and the building was standing strong, so that's nice. But how do we get such a lateral and total collapse from just a little bit of movement? Well, if you look at the wall system, which I've brought to your attention quite a few times, they have an 8-inch block wall, and then that's the outer wall, maybe the inner walls too, some of them, and then they build a 6-inch pad on there, concrete slab, and they put some reinforcement in it. This appears to be 1/2 inch, a little lip, and then they build another block wall on it. But what you don't see, you see this is reinforcement here. What you don't see is the reinforcement going from this wall tying into the floor. You just see the floor's reinforcement from deflection. This is the floor's reinforcement from deflection. I could not find where the reinforcement was really in there. What I did find is, if we go to images, is the city's mouthpiece. He's telling people it's safe, but yet he's not telling how this collapsed. So how can he say it's safe? The same builder built it. Now, just so you know, the guy was not on the take. The builder was not bribing the city. In fact, the city extorted him to pay for the sewage system upgrade by half, or they weren't going to let him proceed. They actually stopped his progress, and they said, your plumbing is you're stressing our system, maybe, whatever they came up with, and that's $400,000. You pay half, and we'll let you get back your permit. So he wasn't, the narrative is that he's bribing. No, in fact, the city extorted him because he had a permit to go ahead. They obviously reviewed the plans and approved it, and then the plumbing inspector comes up with that, let me say, that scam on that plans that say, this doesn't work. Well, I've got plans that say I can do it, so I don't give a shit about you telling me it doesn't work. And they said, what? But the city went to him and said, but you can work, if you split the bill with us so we can upgrade our infrastructure. And they gave in, and they gave the $200,000. And as far as bribing the city officials, gave one guy $100, another guy $200. The $200 guy said, here, take your money back. Sure, I'll get when the developer asks for it back. The other guy said, I spent it. It was $100. So, all right. So that's just for you guys. Now, I think we see it here. The block wall no, it's not clear. Try this one. So some of these walls are solid shear walls. They go all the way up. That keeps it from, they're like plywood on a wall at your house. They go all the way up the entire structure. That is grainy. That is grainy. How about this one? Much better. So the block wall you saw in the wall itself. Oh, that was a headboard on the wall, mounted on the wall. So here's your floor system, but remember this wall is tied together. Well, I bet you wish you could hold them to the headboard. Wow, this person doesn't seem like he had far to fall, does it? All right, I'm going to get back to that in a second. But look at the column here. This is one of the columns, and you can see the interact. I can't zoom in anymore. Sorry, guys. You could see. You could probably zoom in on my video though, and you can come here. So let me move my hand out of the way, and you'll see that the interaction is very limited. It looks like one piece of rebar, two pieces of rebar towards us, and this was wraparound. So there's the deck, three sides of it, and it's not much at all. Now I want to show you this dam. This is probably plumbing or something. This is the holes for plumbing. Our reinforcement, as you see, is going one direction, not two directions. Pretty much one direction being ripped out. Remember the she/her engineer, and I offended two viewers, I think, or is it one? And I don't have time for that sensitivity of you wanting me. I believe women and men are equal, not in physical sense, but in mentality we can be equal. Not physically. That's no. But mentality, sure, you can be an engineer. And with that, you can be an engineer. Also, I don't say that women can't do this or that. It's not me. I am totally believing in women are equal with men, with a lot of things. With that said, she was discussing intellectually about this collapse, and she decided that investigative images are shit. But yet, if you look at her Twitter page, 3 times she's bragging about how she's been interviewed by Miami Herald and then two other people, I think CBS News and one other one. I'm like, really? So I thought your comment would have been, we can't make our decision with these photographs or nothing. You have to wait till, after you had to know what happened before the collapse. You can't use any data here, so that would put NIST, OSHA, and everybody into out of work, and the police investigations, all that would be just shit now. So that's just some weird stuff. So she said he, she. So yes, I did block you. That's making it clear. The person that took so offense and wanted me to somehow treat her differently than I would treat anybody else. And the person I blocked said, "You don't do that. You aren't fair or something." You saw me attack the guy first on here, so it's fair game. I never even considered her. Besides what she brought the subject up of she, her, whatever the hell that is. Now, someone's told me she, her merely means they're transgender. And I'm like, oh, I didn't know that. They text messaged me. And I was like, I didn't know that was a deal. All right, so that's my position on that. And yes, I'm going to be myself. I don't have a channel where I'm trying to be politically correct. You've got the wrong channel. I'm always willing to change my data, though. So back to this. Where the hell is that concrete at? I was trying to show you that there was the 3 pieces of concrete, showing you that how they filled it in. But with that said, let's look at that stripped out there, and let's go to the drawings. So there it is. This is the interaction with this is the 8-inch concrete block. That's the block wall. The interaction with the deck. These are the columns. Would look like this. There's a deck around it. 20 diameter anchors for bars. Oh, 20 times diameter. And there's 30 times diameter over here. I found that very interesting that they bars above for bars which do not continue above. So if you're going to, these bars just need to go 20 times up, and these bars need to overlap 30 times the length. Well, if this floor is poured, this floor here is poured in already, you will not get your 30 times lap. If you've already restricted 20 times up over here, this floor being poured, unless you have the rebar sticking up far enough and going down. This drawing does not show that penetration of the 30 times down. It's called development. It's not developed all the way down. So this is a conflict. How can you have 30 times lap? And over here, you're saying this only needs, wait a minute, for bars which does not continue 20 times above. So it appears that would be the single then, which do not continue above. All right, so we got 2 pieces of bar continue above here. So this is legit. That's cool. I mean, it's legit as far as that detail. Maximum 6-to-1 ratio seems like the bend I think he's referring to. The bend to change format. So let's just again. So these did not quite fail. They did pull apart, and we're going back to why it pulled apart, and that would be because it's no interaction. The flooring and that's a nice dovetail. That's the roof line, I believe. Slide anchor. This is the masonry anchors detail. I thought it was the roof. Parapet, yeah. Or is it the parapet up here? That's the parapet. Masonry anchors detail. That's a pretty damn that dovetail is pretty. And this is referring to the wall tying into the outer wall. How you're going to dovetail that with this? Looks like a steel reinforcement. That looks pretty complicated to do that. And a dovetail design typically just a 2x4, probably flat. And when you do your wall, your grout gets over the inside there. But in this case, it looks like it's not specified rebar, but it's sort of implied rebar. It's bent in this shape that sticks out. And as you build your block wall, you're tying into this wall, so your block wall this doesn't fall out. And wind, it doesn't push in either with the ocean wind. So back to this deck. So how do you get your collapse? So simply is that this is not part of these drawings. There's no interlocking going on here. So when the building shifts, it's just a matter of imagine you put a book, do 2 books, stand them up sideways, put another book across it, and then put another book on top of that. You know, do the same thing and stack up 3 books, and see how easy you're able to shift all the books apart. Now you can tape the joints together of those books now with some tape, with some big tape, packaging tape. Now try to push the books apart. They won't push apart. Well, we don't have the tape here. We don't have the reinforcement tying the 2 together. Gregory, I hope you like that one. Gregory has a couple of analogies that I like too, of slipping out. We don't have this joint on the deck. Here's our punch shear protection slab opening detail. Total number 5 added bars. 5 added bars. Number 5 added bars, same as number of interrupted bars. Number 5 to be each side of opening. T and B each corner of opening. All right, so 1. Does that say 1 number 5? This is just what it looks like. Interrupted bars. Okay. These bars are not interrupted. They go across. Total number of 5 eighths. So that's 5 eighths added bars. Same as number of interrupted bars. So the interrupted bars are 2. So that would be 2. 1, 2. And apparently that's 1, 2. That's all you get. Let's go over here. Whoops. Go over again. So ideally, here are these puncture protection, if you will, to stop it. So ideally, you want to make, so say, oh, wait a minute, I think there's a better one down the bottom here. I thought there was an image that would help me go from there, from 1 to 2. You know what, let's just do this. Let's pretend like this is the column. Each one of those holes represent our columns in our real detail, from here to here. And then I'll show you on the plans. So you have that puncture protection. So if I just put a piece of paper on here, it goes down real easily. But if I had around that the paper here and I put 20 pieces of tape on top of it, right above this point, it wouldn't push down. The tape would stop the paper from going down, right? As I grab the paper. So think of that mat, that paper is the concrete. The concrete will easily punch through, but the reinforcement with the concrete won't want to punch through. So then we go to the drawings, and okay, so 36. So we go to the deck. Let's get to the deck. I think it's 30. Let's just try cheat. Oh, that's not going to work. I was trying to jump forward. Let's now, I'm just going to push forward real quickly. So you've got these floors that are not interlocking with the beams, the outer beams, and you see that with the collapse again. Now we come to the puncture of the deck, swimming pool area, and that open area down here. So here's the swimming pool area, and this is where our butterflies takes place. The butterfly, I think this is where the crack started, and it dropped down around these guys here, stopping on the cars here, but not stopping on the cars there. So much so, a little bit of profile. They stop on a little bit of angle, but by then it pulls on the next one and it works its way all the way over into the structure. Oh, correction. There's where the ramp is. So it's this one works its way down here. So this rebar, this deck. All right. So I think I can do better than that because there's one with the reinforcement showing a little bit a lot better. It takes a second to load. Oh, that would work for me right there. Too late. Too late. All right, so here we go. So let me get this. That's the garage. Let's see, 2'6", 2'4". Okay, yeah. This is where the deck fell down. This path here. It might have moved over a bit when it fell down too. But right, looking at this reinforcement, the puncture. Remember how puncture works. You need to be able to protect the column from the concrete just punching around it. You want to stay on top of the piers, right? On top of the piers. You need that rebar there integral with the concrete. And you need it to go from, so what if I make it really strong here? Remember, it just moves it out to further out to the next point. And we see that when engineers have made that mistake when they move it out just to the next point. Well, let's look at this and I'll get to that. Let's see what's in here. Nine missing, right? So they don't want to put out all those bodies. Their mouthpiece that they hired, he's trying to say it's nothing to see here, nothing to see here. We don't know what's going to happen. Now, I like NIST, but NIST will also protect the municipality in future tax rolls. So they don't want to scare people off and make these things start going for fire sales. And they don't want so they're going to have to say something like lack of repair and maintenance, that rusted rebar in this structure contributed to the collapse. Rusted rebar. And so they're going to do something like that where it does not point to directly. Now, how are they going to? And they're going to have to call it out on the columns too. It's kind of good too. It may force all the condo associations to now do the repairs. But if I was in one of these condos, you can bet one thing: I wouldn't go with a condo with a deck ever. A deck on there. So if it scares you guys off, sell your damn condo. I would not. I would sell my condo if my condo had a deck like configuration like this. I'd cut my losses and move on. I'm trying to show you that one. Is this it? It's so close. Maybe it's over to the left just a little bit. But we see the reinforcement. It appears over here appears two directional. Oh, that's what I thought. I thought the 2-second contractor, because I think I saw better reinforcement over here than I did over there. That I said, wow, this two directional at some point. That's the rebar hanging there. And the other guy, the other direction, the other one was just all one directional concrete reinforcement, pretty much. That's what it was. I found a second direction of rebar. Couldn't remember why. I thought there was a new contractor. That's what it was. The rebar direction changed. So this, I don't know if this is a column or not, but let me get you to. All right, so forget that. Puncture now. Let's bunch out, collapse. Let's try that. So ideally, so you want the columns to the reinforcement to go from one column to the next to be able to take the dead loads without much deflection, because deflection will start pulling on this on the column. We don't want that. So we really don't want much deflection. You know, we got to make the rebar active, and rebar becomes active once it's under tension, once it's got a little deflection. So you want that transition from one to the next. And as you can see, people are pretty creative with their connections. This also lacked shear links and flexural failure protection, but that wasn't it. It was the bottom of the deck. Let's see here. Now, would this building have stayed had their interactions at the bottom of the deck, at the bottom column, and the floor, if it was interlocked better at the columns, would it have stayed? Well, if you're not moving, you're not moving. So that really mounts. Okay, shear, punk shear. Let's just do this. Enter, and yeah. So this is the one I'm talking about. This is one of my favorite ones to talk about. That I like this one the most. It identifies what I'm talking about. So here the mat protect and the reinforcement is further out, and over here it's a lot less. So the reinforcement was not tied into this column and out here, and this is more the failure that you're looking at here. It's even worse than what we're looking at here, but you can see here the rebar is where it's not even present. It just stripped down. Maybe they pull the forms out too quick, but there's a pipe. Looks like something on the ground that was already underside of the structure. So the whole thing here is the reinforcement didn't make it to this side. And so the load of this, the dead loads of this, just punch sheared around these columns. That's all you're looking at. That's as simple as that. And the same thing, so punch shears here. And why did it happen? Because we're getting cracks in the deck, in the deck, overloading possibly, and they're not connected. That's a major issue too. It's not connected. We saw that at the pools location where the people are standing gathered around. I understand it's NIST over there. Cantilever, column strip. So what we got here? Again, I don't see the interaction of the rebar. Typical middle. I don't see the interaction of the rebar on these plans. And these are the S stands for structural sheet. And they're the tie beams with two number 5. They're very cheap on the rebar reinforcement. All concrete strength to be shown on plans, if not otherwise specified. The PSI will be 3,000 PSI, which in the steel 60,000 grade, 60,000 PSI, which is typical steel current day. This was the 1976 building code. It's in here somewhere that they're referencing it. All piles to be 14 by 14 precast concrete driven to 50 tons. All right, that's for that. That was part of a lawsuit, whether it was the piles. That's it. All concrete work shall conform to all requirements. So those 50 tons they're talking about, well, that's obviously, you can do the math. If a ton weight, 4,000 pounds of concrete gets you about 1 yard, about 4,200, 4,400, depending on the stone mix. But about 4,000, you can say 2 tons will get you 1 yard. 1 yard at 4 inches gets you about 81 square surface feet at 4 inches thick. So that's 1 ton. So that's 2,000 pounds, right? So I'm sorry, that's 81 square feet at 4 inches will get you 4,000 pounds, 2 tons of weight. But that's distributed amongst the 81 feet. But it's got to make its way back supporting onto something. So in other words, I'm telling you, it's only 4,000 pounds 5,000 pounds, 10,000 pounds here, and they said run it to what, 50 tons. So these columns did not puncture into the ground, which they can do also. Puncture can also punch into the ground also, but that's not happening. The factor is amazing here. That he has it at 50. I just saw it, right? Where was it? 50, 50. Right, I can't search the document. Like I got to read the document. I can't search with my search way. Oh. Can be at center beam or slab if required. No horizontal construction joints shall be made in beams or slabs. Which is very critical. What the hell's a 50 tons? I just saw it, right? You guys see it? I'm just looking for the bottom up now. I'm not reading where the arrow is. Right here. All piles to be 14 by 14. Precast concrete. Precast concrete driven to 50 tons. Precast concrete driven to 50 tons. So that's amazing. You think you're going to drive a concrete pile 14 by 14 precast down 50 tons. I don't think that happened. It would fracture and you would damage it. So that's not quite the way. That's part of the lawsuit, that whether they argue over whether they used piles or the damn guy. I forget the name of the guy. The other ones I showed you in the video. Yeah, I got the name, lost it. Whatever. Pressure induced forms, columns. So again, you're not getting this is going to be a rebar thing, the interaction. So when you don't have that interaction, that rebar from the deck, or you just got this block wall sitting on it, and it's very minimal in the block wall. You guys got to realize how minimum that block wall is. It's glass there, and that glass just bridges over, all the way up. See, it just bridges over. That's glass there, but there are floors inside here. But the glass, this is just a wall of glass. Now there is a floor in here because they come from the bedroom right here, I think, and they come out to the porch here. From what I gathered, it's floor to ceiling glass, and here same thing over here too. It's a lot of glass. It's real. I mean, the apartments really are pretty, condos rather. And then there's a single column in here, and then they packed it out however they did. This had plenty of repairs in 2002, structural repairs from the top to the bottom. I mean, this guy, it's a huge report. He did tons of work. The 2002 engineer, tons of work. The penthouse, reading on that further in this with the city's documents, they seems like you can add a penthouse if so you can build it. You can get a permit to build a building, say 12 floors tall, and then through some ambiguous wording, you then can say, I'm adding a penthouse. It's like it's part of the building, but it's not. It's not a full floor. Everybody gets a penthouse or something of that nature. If you go all the way around this building and look at the front, you'll see a light broken. So that speaks to maintenance and how cheap the maintenance, how they don't even stay on top of that, and it's an electrical issue also. Okay, so the building did have a nice, pretty look, but it seems like the owners didn't do it. All right, conspiracy theory. What do you think? What are the odds that the Israelis send over people to help pick up debris by hand? What are the odds that in that group that there are not some military people that are really looking for criminal actions that might have taken place at this building, and they're there to confirm that no criminal action took place through, letting them come in through the State Department and take a peek. Just like we go around the world too, looking at our actions to confirm the FBI. Everybody goes around to help, but in this case, they disguise themselves as people that can pick up debris with a square shovel. Yeah, because I don't think we need people from around the world to come to pick up debris. We got plenty of people that can pick up debris here. So this video is about puncture. trying to show you the interaction, that why the building collapsed so easily there, and why it only went over about 15 degrees or less from the top, and then all of a sudden it just collapsed, pancake down. That's because it broke all these connections, and there was nothing else left, to hold it up. So that would be, if you watch buildings that have the tension side of it. So building rollovers. So building rolls over. Let's just try that. Okay, Rolls Royce. Buildings that. Oh, looks like I got to finish the word. So right here, the building rolls over. So what's important here, and my man Danny sent me a video. This new guy that's only got started channel 8 months ago, an engineer. Now all of a sudden he's doing topics on this. Well, he doesn't mention this because he doesn't know. But how is this building able to roll over? At some point, this building is rolling over this way. All of these columns and floors are still connected. So they got good tension in them. They've got good interlocking connections. They have good interlocking connections from one floor to the next. And it's able to stay together. On this building, when it rolls over, it goes about 15 degrees, and the spine, it's like a spine of a person's back. It opens up. And it opens up, and once it opens up so far, then it just pancakes down. It just collapses down. So that would be, and these guys are capable of rolling over because the floors and the columns are all interlocked with good steel. And that's how we know that this building was lacking steel interactions at those connections, because it didn't roll over like this. And that would be the video of, what's the Surfside? So let's go to Surfside building collapse and video. Hopefully they'll, oh no, I don't have to go to video. So right here is the crushing of all the materials. It went over about 15 degrees, and then you could see the railings and the deck behind each other. Those walls just separated. Whereas all these other buildings that you saw just roll over. This building will also, when they go to demo it, will just roll over. You just got to get it 15 degrees off, and it's gone. It's going to do the same thing. It's going to collapse because the interactions are the same. Although this builder over here, I told you, it seems like a different builder at that point. But they did have that shear wall there. So what do I have here? Again, that would be videos. Let's see if I can show that to you again. 30 seconds or so. That's too long. Looks like we're going to have to do that one. Let's see if we can find it to prove my point. So intelligence, what? Intelligencer. Please show me the damn video. Okay, nothing to see here. That's the wall. It's so small of a span. There's nothing there. That's just, it's chlorine in there, etc. All right, that's the lady walks up there. Oh, great. Okay, here we go. All right, so then let's see if we can. So we see it all stockpiling there. That's the column that failed. And now watch this building here. The spine, now it should be able to just roll over and stay on its side. But as it moves about 15 degrees, those interactions, and I spent this time talking to you about, these interactions aren't there. And so it doesn't act like that one video I showed, the building rolling over. It acts like the spine is broken, and then it just rolls over. Where the hell did it go? I'm looking at my tabs. And there's the corner of it. It went that direction, as you can see, literally that direction. You can see the railings on top of each other. That's how much, when it changed out that 15, when it shifted that much, it just collapsed down, breaking all those little silly connections that they did use. Where the hell is the video now? So we don't need that one. Let's get rid of it. This is the stock of the company that owns it, part of that other building. Yes, I think the south one. Okay. So then there we go. coming, gone. It does a little bit of rock. It hits it, so that would be like that earthquake thing. A little bit of a rock. Now it probably buckled one of the columns down here, or the front wall rotates and pulls it. Remember, this is silly interaction. It really is terrible interaction with the floors and the beams. And so it doesn't take much for this to move back and forth and then all of a sudden fail. Now watch how much it comes out of plane. I want you to look here. It's right under the H, I guess. And watch how much, there we go. It doesn't come much out of plane. Oh, that's right. Somebody told me they filmed this from their cell phone. Here's plumb, I guess. And it just comes about that much out of plane. And the spine of it, which is all it connects, just breaks. And just collapses. It's in tension back here. And in the front part, it just shifts like that book I told you about. And there it is. Just buckles all the way down. And so that's why you get that. Looks like an implosion. It's not an implosion or explosion devices. It's because of the lack of interactions of the columns that you don't get the same deal as a rollover. Where's my rollover? Hold on. My rollover. Where'd you go, rollover? I'm trying to show you the rollover one more time. Let me look at the. I'm looking at my tabs up top. Nope. Well, that's interesting. I got a couple tabs left. Hold on. Frankie piles. That's what it was on that, what we were talking about earlier. There's NIST. Thank you for your whatever. We don't need that one. .4K video. That's about nothing there. Towers are. Oh, this is the ground floor. Thank you. Someone sent me this. I didn't. So appreciate it. I guess you know who you are. I'm sorry about if I didn't reference you. So this is the ground floor. What it looks like through the that ground floor. This is one of the exceptions they got, was the allowed to be able to use that as a living space, which they don't allow anymore. The first floor to be used as a living space, and there it is directly out. So this is the first floor, and you step out onto a little deck. I mean, it's well, the building is immaculate. I mean, look at this thing. They were high dollars. It makes sense to be high dollars too. They look beautiful. But that deck was the Achilles heel of it. It looks like I'm not going to be able to show you that rollover. It looks like I might have deleted it. I deleted the tab. Ending video. I hope this.